Hello, are you laying down in bed, Alex? You didn't realize your video is on, did you? That's okay. Always check that. My girlfriend always has a piece of tape over her laptop. Oh, that was weird looking, wasn't it? Virtual background. My girlfriend always puts a piece of tape over her laptop camera just in case she forgets or she gets a virus or malware on her computer that turns on the camera. Unfortunately, sometimes that happens. Okay, I apologize, by the way, for those of you that are here already. I did not get a chance to edit the video yet, to put the video of our first lecture online. Immediately after the class, I had to go back to working on that lab project I've been working on, which I worked on till midnight last night and then got up at 6 in the morning and continued it. So I'm in a good stopping place. So tonight, guys, I will be able to post both the first class video and this video on YouTube. The password will be the same as the GoCougs password, the same password as I use for Zoom. I'll send out an email to make sure, because I'm not going to have a full class today, I'm sure, because I didn't send out an announcement yet. But we generally, just for future reference, we generally meet online synchronously Monday through Thursday, and I've mentioned that before, Monday through Thursday. Friday, I'll probably do this Friday, but rather than have a class, I'll have a question and answer session over where I think you guys need to be and what you should be working on. Now, I'm still working on setting up virtual machines for you and setting up the Proxmox servers. I'm going to do that part for you guys so you don't have to install Proxmox. But I want to go ahead and show you what some of the Proxmox GUI front end looks like. Excuse me. And in place of this, if you want to get a little bit ahead, as I mentioned in the previous class, you can install VirtualBox and begin to do the same kind of thing that we're going to do with Proxmox, and that is download and install a distribution of Linux and begin to learn Linux. Okay? I'm going to share a screen here. So pull my chat window back out. Can everybody hear me okay? Who's here?
I can hear you.
Okay, great, thank you. Where'd my chat window go? Oh, there it is. Move it over here. Okay, so I am going to use Chrome Remote Desktop, which is ultimately, I do want everybody to try using Chrome Remote Desktop, even if you decide upon using TeamViewer or VNC or some other method to remote view the virtual workstation that I'm creating for everybody on the EI Lab network. So you guys can all see my screen. I'm sharing a screen here. Let me close this PowerPoint from the previous class real quick. Go away. Okay. So I'm logged into my Chrome account here. I'm going to click on this little icon here, remote access, and it's going to give me a list of a bunch of computers. I've got a bunch of computers that I can log into remotely. This happens to be the name of my virtual machine that lives on the EI Lab network. This network, the EI Lab network, is a closed network. It is attached to the internet, so you can surf web pages on the internet, but it is not a public network. So that means you can't access the servers from the outside world without using some sort of a back-end method to get in, such as a remote viewing program. It's behind firewall routers. So I'm going to remotely view this computer. In the case of Chrome, how many of you, by the way, have used Chrome before? Excuse me, not Chrome, but Chrome Remote Desktop. Jessica, I think you've used it, right, in the previous class? And Randy, maybe, I know a couple of you who've taken my classes before, you have used it. Has anybody used it who has not taken my class for anything? You've not? Okay, so if you've never used any remote viewing software, be prepared to be amazed because it's cool stuff. So anyway, I'm going to use my PIN number, which you can optionally save, but I don't like to do that. Now, I happen to be, I'm remotely viewing another computer. So I'm on my laptop here, and I'm sharing screen 2 of my laptop, and I'm remotely viewing the screen, and there's my start button of my Windows 10 computer there. But then here is a start button of this virtual machine I'm viewing that lives in the cloud. Just that, so that it's the size of the screen. So there it is. Happens to be, this is a Windows 7 machine. I'm going to upgrade them and make them all Windows 10 machines if I'm able to, if I get time to. And close all this junk. Get rid of all this junk. Okay, so I'm going to log in and show you. This is a legacy server from the previous semester. I'm going to blow all these away, but in the meantime, let's use one. Let's see if any of them are still running. I don't know if any of them are still running or not. We'll figure out real quick here if they're on or not. Oh, this one's on. Can you guys see this okay, or do I need to blow that up a little bit? Okay, yeah, so some of you might use Citrix at work, some of you might use Hyper-V at work, or you use some other remote viewing software. We actually here in the lab, we do use the Citrix Zen desktop to remotely view programs running, applications running, excuse me, virtual machines running on VMware. I'm sorry, I think I typed it wrong. Oops, wrong password again. What am I talking to? 192.168.20.100. Oh, I had the caps lock on. Hate that. Always hitting the caps lock. Ah. Let me try a different one. One of them I'm sure is running. I'll go run over there real quick and turn them on if they're not on. We'll find one that's running. Let's try that one. Oh, gee whiz, now Chrome doesn't want to work. Hang on. Kill all these Chromes. The user in most cases for most Unix and Linux machines is root, by the way, not administrator. Okay, what we're looking at here, oh my God. I don't know why I can't log into anything. I'm gonna try one more, and if it fails, I'll log into one of my own personal ones. There we go. Okay. Proxmox 5 and 6. Okay, so this is what the console screen, well, not really console, that's not the right term. The desktop for the virtual environment looks like. And if you did a little bit of pre-work as I asked you to do, you went and watched videos or you checked this out. Over here in the server view, data center is always at the top, and then I have one or more servers listed. There happens to be 2 servers here because these 2 servers, these are 2 physically separate machines over there in the rack. They're clustered together and they're operating as if they are one virtual environment. With Proxmox and with Hyper-V and with VMware, you can have more than one virtual server, or excuse me, more than one physical piece of hardware offering the virtual environment. In fact, that's true in most cases on the internet. We don't, in other words, we don't put all of our eggs in one basket. If one server physically fails, another server can take over and run those virtual machines. So what we were doing last semester is I was showing each of the teams this, and I had team 5 and team 6 choose to pair up. We had teams 1 and 2 pair up, 3 and 4 pair up, 5 and 6 pair up, and 7 and 8 join themselves to a cluster so that they could experience using a multi-server cluster of machines. Make that a little bit bigger just so that I can read it. It's a little too small. Oh, there we go. That's how we do that. Okay, so if I'm going to click on Proxmox 5 here and expand that a little bit. Now on this third layer, you'll see that I've got what's called containers. There's one running right there. Anything that's grayed out is not running. It's turned off. There's a container. There's a virtual machine. Let's take a look first at this container. We're going to look at the summary of this container. We got a notes box here. This is just where I can enter notes on this container. The status says it's running. It's running on this node. Here's its current usage. It's literally hibernating. It's not doing much right now, and that's because it's generally a server. It's using 2% of its 512 megs. It has hardly any memory at all. It's not using very much of its boot disk size. I only gave this container, or the student only gave this container, an 8 gig hard drive. We don't have to give containers a lot of hard drive space. If I click on resources, we can see what was associated with this container. We allocated 512 megs of RAM, not even a gig, half a gig of RAM, half a gig of swap space, which is like a cache space, one processor. This is a relative speed, how fast I want that container or that virtual machine to be. And there's where its disk is stored and how big the disk is. Networking. You can give a virtual machine one or more network cards, quote unquote, a network card, so that it can communicate with the internet. And we actually are hard coding. In our case, we're hard coding IP addresses because these are servers. We want them to be non-moving targets. But we certainly could have used DHCP here if this was a workstation, for example. And here we specified DNS information, the domain, the DNS server, the name of this server. Options, when do we want this thing to start when we boot the Proxmox server or not? We can change the OS type, or we can specify the OS type, I should say. We can change the chip type. We can look at the task history, see how many times this particular virtual machine has been rebooted or viewed or turned off and on or shut down. We can back up this container. We can, and this is one of the real advantages to creating virtual machines, is we can literally create an image of the entire virtual machine rather than just the data. How many people have used a backup program to back up data on a computer that you had that was important? Then the computer crashed and you had to go buy another computer or buy another hard drive or reinstall Windows, reinstall all of your programs, then recover or restore your data from Dropbox or CrashPlan or Carbonite or whatever you're using. It's a very, very, very long procedure and a long time. You're having connection issues. I'm sorry, Jessica. You're having connection issues. This is being recorded for those of you that are missing it. So hopefully you can watch it on YouTube later. I promise to get them edited and uploaded tonight. In a virtual environment, when I choose to back up a virtual machine, it backs up the entire image, the OS and the data and everything, so that I can migrate it or restore it with the press of one button. Might take a little while, but it's one button press. I love virtual machines just for that. I can back up the entire thing, not have to go through a multi-level process of reloading Windows 10 and then reinstalling all of my applications that I had and then recovering the data. It's very difficult to do that at the Windows level and at the Apple OS level, to back up an actual image. I can replicate or clone. I can make multiple clones of that container if I wanted to. If I created a great workstation, I thought, hey, this is neat, I want to share it with 100 students. Here's a good template to start with. Let me replicate it 100 times. Snapshots are kind of like backups, but this is another really cool thing about virtual machines, whether it's a container or an actual VM, is let's say I want to install a piece of software. And this is true for almost any virtual environment, whether it's VMware or Proxmox in our case. Let's say I want to install a particular application, but I don't know what it's going to do. Or maybe I just want to experiment. I want to install WordPress, for example, or Apache web server, or I want to make some changes which may mess up the server, may make it not bootable, or may have negative effects. So I can essentially take a snapshot, oh, I can't have a dash. Good. They're very picky on names. And it will literally copy, or it basically sets a bookmark on that virtual machine. It copies what's in RAM. And then I can go install my applications or whatever, play with them, whatever. Then I can roll back and I can say, well, I want to roll back to a previous time, a previous point in time. Windows has something like this called System Restore. It's not exactly the same, but it's similar. You can roll back your registry in case your system became corrupt and not bootable. Occasionally, you have the ability to roll back the hands of time and go back to 2 weeks ago. You're going to lose data. You're going to lose information, but snapshots is an important part of using virtual environments. I'm going to put my hat on because I'm tired of looking at my hair. Firewall permissions, these are other things that you might want to do. Now, I mentioned before, and that's okay if you don't understand the conceptual difference right now between a container and a VM like this. They're essentially the same thing, but a VM is more standalone, but it has pretty much the same entries. There's hardware here. Virtual machines can be, they can be Windows machines. These happen to all be Linux machines. Let's see if anybody has any Windows VMs running. Or clone. There's some clone machines. Nope, I don't think I see any Windows machines, and there's only a couple of machines actually running. If I wanted to, I could get a console, or I could remotely view, or I can view that machine without actually having to remote view it. I can basically get a console to it, or I can do a pop-out console like this. Log into it. It's a completely different, in this case, because this is a virtual machine, it's completely different. The usernames and passwords and all the code that's installed is different than the actual server, Proxmox 5 here. It's running its own set of stuff. Now, as I mentioned before, and you guys probably want to do this, it's not for a grade, but if you have a powerful enough computer, which is pretty much any modern computer, any laptop, you should probably experiment with, at the same time, downloading VirtualBox. Doing this at the same time as we're working on Proxmox. Download and install VirtualBox as an application first, and then download and install an ISO and create a virtual machine on VirtualBox, and then try creating the same virtual machine in Proxmox, and then later on we'll do some experimentation with migrating a virtual machine that you created on VirtualBox to see if we can make it run in Proxmox. That's a neat thing, and that's what a lot of developers do. They use VirtualBox to create a server or create a virtual machine how they think it should operate, and then once they're comfortable with it running on their own laptop under VirtualBox, then they deploy it to a public virtual environment like a Proxmox or a VMware, and then duplicate it 50 times and make that available to their employees or their customers or their end users. We can do that with VMware and Proxmox. You can actually create images that you can export and import. So not all virtual environments, but most virtual environments let you export and import virtual machines from one to the other. Pretty neat stuff. So how do we create a virtual machine? Well, first of all, we have to start with distribution. Here, you'll notice these icons here, they look like stacks of pancakes. That is the generic icon for storage. Whether it's hard drive storage or solid state drives, we still use the little pancake icons for storage. So if I click, I'm going to click on local here. I'm going to see if I have under content here, see if I have any, well, there's a bunch of backup files. Here's some ISO images. These are DVD images that have been downloaded. We went to CentOS.org, either I or somebody else or somebody on this team downloaded and then uploaded these ISO images to the Proxmox server. So this is one of the first things you're going to be doing after I give you access to your Proxmox server. I'll give you a username and password, and you'll log on to Proxmox123456. You're going to go look and see if there's any ISO images there. Probably only going to put one, and then I'm going to ask you guys to experiment with finding, researching, and finding your own ISO image to upload so that you can create a virtual machine. So let's say I want to create, this is a large 4.3 gigs. It took a long time to download that one. That is like the full CentOS package with a bunch of different applications in it. Let's go create a virtual machine of CentOS 7. So I'm going to click Create VM. Which node do I want to create it on? I'll create it on Proxmox 5. What do I want to number it? Proxmox starts with the number 100 and rolls up from there. This is just a unique number for that virtual machine. I recommend that if you're on Team 5, you start all your Proxmoxes with 5. So I'm just going to call this 5009 just so that it doesn't run into anybody else's. I recommend that each team, and I'm going to randomly assign everybody to a team. You can log into Blackboard later on and see what team you're on. Everybody needs to communicate with everybody else, and I'll help you with that. And you're going to all share a document on Google Drive. That's probably the easiest way to do that, with virtual machine names and contact information so that you don't step on each other's virtual machines. I just call this CentOS test. Click next. I'm going to use a CD image. You could, if you actually had a physical CD and you had physical access to the machine, you could stick it in the drive and install it. I need to tell it what kind of OS it is. It's either Linux or Windows or Solaris, or could be other if you're not sure. Like if you're installing FreeNAS, which is a common distribution that's installed, that's BSD. So they tell you to choose other. There's different versions. There's the old kernel version. This is, usually you can just choose Linux 5 point something. I need to choose which image. I'm going to choose, oh, that's on Proxmox to shared local. On the local storage, I've got, there's that DVD I downloaded, or uploaded, I should say, uploaded to the server a long time ago. I'll click next. Graphics card, you can specify if you want to specify a specific kind of graphics card. Usually we just choose default. We don't change that at all. The controller, we can choose to emulate. This is all emulation. This is virtual. We can choose to emulate a special SCSI controller or IDE controller if we have to. Usually we want to choose VirtIO SCSI. Usually we take the defaults. We can't do that with Windows because Windows doesn't have a VirtIO SCSI driver. You have to download it. So we typically have to choose something else like IDE or ATA. And you'll see that if you try to go to install a Windows VM. So I'm just going to choose VirtIO SCSI or keep that as the default. I'm not going to worry about that. Hang on one sec for me. Okay, next. Again, I can choose IDE or SATA. These are all hard drive types. SCSI, VirtIO, SATA, IDE. I'm going to choose SCSI because that's the fastest. That's like an Apple-ish invention. Storage, what do I want to store my, my hard drive image? I'm going to choose that CT1. This is it's got plenty of space. So I'll choose that. How big do I want to make the disk? I'll make it just an arbitrary 40 gigs. Cache, I'll choose write-back cache. If you don't know what caching is, go Google for that. Click next. I'll give it 2 cores just to make it a little bit faster for installation purposes. I'll leave it at the default processor type of KVM64, or if I wanted to experiment, I could choose, you might recognize some of these old processor types, like the old Pentium or Core 2 Duo. You can specify the type of chip that you want to emulate. Again, I'm just going to go with the default there. Click next. Memory, I'm going to bump that up to 2048 or 2 gigs. Virtual machines need a little bit more memory than containers. Next, network card. I've only got 2 choices here, VMBR0 and VMBR1, and that's because I have 2 network cards in this server. I'll just choose the first one, 0. Oh, and also I could have chosen whether I wanted it to be the old Intel chipset network card or Realtek or VMware, if I was going to create an image to go over to VMware, or this standard, this default VirtIO network card, which is the fastest one. Click next. Verify that's all good. I'm going to click finish. I just created a virtual machine. That's not going to do anything yet. I just created it. There it is, CentOS test. It's not on yet. I'm going to get a console screen to it. Oops, where'd it go? Now it says failed to connect because it's not on yet, but I'm going to click that little start button there, and I'm going to start it. And this is what you should see when you start up a virtual machine. It's literally It's just, has anybody ever installed Windows or installed an OS from scratch on bare metal? Anybody ever installed Windows before? So this is kind of like what you would see if you were installing CentOS from bare metal or Windows from bare metal. You'd see, welcome to Windows, or welcome to Microsoft, experience Windows 10, blah, blah, blah. And then it would start asking you questions like, what country are you in? What time zone are you in? And that's basically what's going to go on here. CentOS 7, which is not the latest CentOS, but it's kind of equivalent to Windows XP. It's going to ask me similar questions. It's automatically going to boot in 30 seconds. I'm just going to hit enter. And I'm going to go through this installation procedure. We do not do this with a container. A container is an already ready to go template. It just starts up and I can change my username and password or specify. When I build a container, I specify a username and password in the container build. When I build it, you don't do that with a VM. You have to actually install the VM. Then sometime during this process, it's going to ask you, what would you like to add some new users? What should the names be? What should the passwords be? Now, if you install VirtualBox on your laptops, which again, I recommend everybody who can do that because VirtualBox is free to download. You go to CentOS.org and you download a CentOS DVD, and you're going to go through almost the same process. The screen, of course, is going to look different. It's not going to look like this, but it's going to look very similar. And VirtualBox is really only designed to run one guest OS at a time. They call it a guest OS. Whereas Proxmox and VMware are designed to run multiple guests all at one time. Oh, didn't mean to do that. I meant to do this. Now, depending on what you're installing, it might be a GUI installation. It might be a text installation. This happens to be a GUI installation. Now, you'll notice something weird first of all. See how there's two mouse pointers? There's my white mouse pointer, and then there's a black mouse pointer that's kind of lagging behind. The black mouse pointer is actually the mouse pointer of the virtual machine I'm remote viewing. So right now, I'm remote viewing a virtual machine, which is remote viewing another virtual machine. Sometimes in this class, it gets a little bit like that movie Inception with Leonardo DiCaprio, where you're within a dream, within a dream, within a dream. Did anybody watch that movie Inception? It got really confusing after 4 or 5 levels of dreams. I'm like, I got a headache. Let's stop watching this movie. It's an okay movie. It's not as good as The Matrix. The Matrix is basically one dream. I understood that part. And Kung Fu, I understood that part. But what level of dream am I on? If I die here, I'm going to die there? I don't know. It was confusing. So, welcome to CentOS. What language do you want? I don't know. Let's go with English, since I am English. And I'll go with English United States. Oh, it's scrolling off the screen a bit. I can't quite see everything, so reposition that so I can see it. Continue. So everybody's going to do this at some point in the class, preferably sooner than later. And so, like I said, even before I've got your virtual machine set up, you can do this tonight if you want to. Go install VirtualBox. Go download CentOS. It's going to take a little while to do the download. In fact, I would recommend starting the CentOS download first, then go download VirtualBox and install that while CentOS is downloaded, because it's 4 or 5 gigs. There's different flavors of it. There's a minimal version, an everything version, a net install version. Download the everything version. That's this GUI version here. I can choose my date and time zone here, so I'll click that. I'm in Central Time. So this looks a little bit like a Windows installation, right? We're all in a dream right now, maybe. Yeah, the COVID-19 dream. It's not a dream. It's a freaking nightmare. Please wake me up, Hoa. Or Jessica, whoever said that. Yeah, somebody needs to wake somebody up. We need to get woke. I need to check something real quick. I've got lots of messages on my. No, I'll check that. Actually, let me check something real quick. I need to make sure something is operating. I could be in trouble. Hopefully not. Okay, these seem okay. I need to check a server real quick because I'm getting text messages from multiple people that usually concern me. Check a dashboard real quick here, just real quick. There. Things look okay. All right, I'm going to assume that we're okay. I'll call those folks later. Date and time, I'll go with that. Where's my next button? I can turn on network time there. Here's my done button. It's a little bit different than Windows. Installation source, I've already got that. Software selection, let's choose, you can choose to customize your server. This is kind of cool, and it's a little bit different than Windows, is I can make some general specifications. Let's make this a GUI. Let's make it a server with a GUI so that it's like it's got web services on it. I did configure. Oh no, let's choose that. Let's see what that does. And I can optionally add some additional applications. Let's just be crazy and let's add everything. It's going to be a nice, we don't need to add legacy compatibility. That'll actually take a long time to install if I do that. Destination, I've already got a disk there, so that's good. There's that 40 gig disk that I created. Network on configure, I'm going to configure it for DHCP just so that I automatically get an Ethernet address. IP version 4, not 6. Save. Done. I think I'm good. I think at this point, I can do other customization, but I just want to show you what the beginning of an installation of a GUI environment, something other than Windows, looks like. Begin installation. Now, it's installing. While it's installing, I'm going to go ahead and set the root password. Again, root is the same thing as the administrator user on Windows. I'm going to set it to something real simple, just 1, 2, 3, 4, 5, 6. I don't recommend doing that, but make sure when you do this, especially with a virtual machine, you remember the password that you set. Otherwise, you have to jump through some hoops to change it. So the first time that you do this, just make it a simple password. Make it your student ID, okay? Make it something simple. Done. I can add additional users if I wanted to. As a matter of fact, I usually recommend that you do that on a virtual machine. Add yourself. You don't typically want to do things as the root user. In fact, Windows 10 prevents you from doing anything as the administrator user. They force you to create a user that helps people not screw up their machines, if you know what I mean. They say, don't log in as the admin unless something happened and you have to log in. Log in as Jake or Johir or Karen or Raul or whatever. Log in as some username. Click on advanced. I'm going to make Jake a member of Nah, forget it. I'll just do that. And it's still installing. Okay. While that's installing, I can look at some stuff over here. Look at some statistics on that virtual machine. That CPU is bumped up to, ooh, look at me, I'm changing colors. Can you guys see my face at the same time as what's on the screen here, by the way? Am I up in the corner? Okay. I hope I'm not too distracting. So you can see the CPU usage bouncing up and down. If we scroll down here, you can see memory usage going up. These are all common statistics. Network usage, memory usage, CPU usage. You won't see the network usage very high unless you're doing what's called a net install. The net install is a much smaller downloadable ISO. In fact, you might want to try a net install. You gotta do a couple more steps, and you might get stuck if you're not following like a video on how to do it. So usually I just recommend people download the everything, and then you don't have to worry about a net install, which will go out on the internet and find the distribution. It gives you just enough to get booted up. And it says, I'm gonna go find distribution on the internet, download it, install it at the same time. You'll see that network thing spike up if that happens. So when I see this CPU usage go down back to like 1% or 0%, I'll know I'm done. Or I could just, look at the screen. But in the meantime, while this is installing, I go build another virtual machine. I can go do a Windows installation if I want. If I look at the Proxmox summary here, Proxmox 5, its CPU usage is not very high, and that's because it has 4 CPUs in it. I'm only using, well, in this case, 2 CPUs, so it should be about half. It's bouncing up and down a little bit, but not very much. So that's kind of neat, isn't it? I can install 4, 5, 6 different machines all at one time while I'm watching TV or doing something else. Or I can install one virtual machine and then press a button and clone it 10 times. That's what's really cool about virtual machine installations. Let's see if we're almost done. We're almost done. Let's see if we can get this to finish during this class here. I'm just texting a client real quick. You may do the same. I'll edit this out of the video. It'll be too slow. We'll skip ahead a little bit. Let's see, what else can I show you while that's happening? Let's look around a little bit more in Proxmox. Has anybody started to download VirtualBox, by the way? You could be downloading VirtualBox at the same time. Download VirtualBox, get that installed, and then, yeah, actually, let me show you what the procedure would be, by the way, to install a new DVD image. So let's say I wanted to install some flavor of Ubuntu. I'll just go Google for download Ubuntu. I'll go to ubuntu.com and I'll say, okay, I want to download, Ubuntu 20, cool. Let's get that. LTS stands for long-term support, by the way. That basically is like 4G LTE. That's all that means, by the way. Download. It's probably huge. Thank you for downloading. Screw you. I don't want to answer it. There, it's an ISO file. That's what you're looking for. You're looking for an ISO file. It needs to be something, something, something.iso. That's how you install a virtual machine. 40 minutes. Screw that. It's going to take forever. Anyway, that's how you would do that. You would download that, and then you would come back to Proxmox here, and then you would go to your what's called local storage or shared storage. I've got some different storage opportunities here. I've got CT1, which is some shared storage. I've got Proxmox 2 shared, which is actually storage on another computer somewhere else. And I click upload. I select a file off my local hard drive. I'm going to look in the downloads here. Let's just pretend that's the thing. It's not, but let's pretend that's the thing I was downloading. I'll click open, click upload, and that will upload to the server. So it's kind of a two-step process with Proxmox. I have to first download, I have to first find an appropriate ISO that I want to experiment with. Hang on, be right back. Excuse me. Look at that. So find an appropriate distribution. I recommend CentOS, Debian, or Ubuntu. CentOS 9, I think, is the latest CentOS. We go to CentOS.org. 2 hours. That's going to take forever. It's because I'm on a kind of a slow network here. I'm on a laptop through, so I'm not directly connected to. Oh, you'll notice something about distributions. About Linux type distributions or open systems distributions is this thing called mirrors, the concept of mirrors. There are multiple places that you can download distribution from on purpose. What a mirror is supposed to do, and what mirror essentially means is it's a repository or a distribution site. And there are many mirrors for CentOS, many mirrors for Ubuntu, and many mirrors for Red Hat, Fedora, all over the world, or in Debian. You choose the mirror that's physically closest to you. Now, usually this list is supposed to be a list in order of what's physically closest to you. You can't really tell by looking at some of these where they are, but some of them you can. Like, for example, if I did Control F, look for Texas. Nope. How about TAMU? Nope. Sometimes you'll see tamu.edu or utexas.edu. That's University of Texas, Texas A&M University. They are popular mirrors for a lot of the distribution, but let's just choose that first one. You'll notice that all of the names, if we were actually to go back there, you'll notice all of the names of the distribution, everything to the right of that / CentOS 8.1.1911/x8664. That's all the same. And you can actually download older versions, but let's go click on mirrors here. See if there's any in Texas. There's one, TAMU. Let's go to Texas A&M University. You can see that you can go to CentOS 2 if you wanted. You can go back 20 years in the past and download an old version of CentOS. Try doing that with Windows. Can't do it. There might be a version 9, but it's, or a lot of times you go to one of these mirrors and you'll usually see a folder or subdirectory called current. If you click on that one, you get the most current commercial version that's available. I'll choose 8. And I'm going to look for, I'm looking for, and here you can download, by the way, the actual source code if you wanted to. You can download the source code and modify it. This is how hackers hack. They download the source code for operating systems and they look at it. Or you can go to the ISOs folder and either download Arch, PPC, or x86-64. This is what we want 99% of the time. If you don't know what these other things are, ignore them. x86_64, that's AMD/Intel processors. Here, you can't quite see the whole file name, but if we hover over them, you'll see there's a boot ISO, manifest, BitTorrent. Stay away from the BitTorrents. There's the DVD. I'm looking for the net install because it's going to be a lot smaller. If I can find it. Not every site has every version. Let's see how our install is going, by the way. It's probably done by now. Yeah, still going. It's taking a long time. Anyway, ultimately, we will come up with a machine that's going to have a GUI on it. It might look like Windows, might look like Mac. It's going to look a little bit different. Here's another cool thing about Linux distributions. With Windows 10, you basically get one GUI experience. With a MacBook Pro, you get one GUI experience. With Linux, you have a dozen different desktop experiences that you can download. You can use what's called the KDE desktop, the GNOME desktop, the Mite desktop. There's a bunch of different desktop packages that you can download, which will make your GUI experience a little bit different. In fact, there are GUIs that you can download that emulate and look like Windows. You can Google for that if you want. You can say, I want a Windows-like Linux GUI. Let's see what comes up when we do that. Zorin, that's it. That's what it's called. Zorin is one of the most Windows-like distribution of Linux. So if you want to, you can go Google for Zorin OS. And usually what it's designed is you don't download an ISO of Zorin. You download CentOS or Ubuntu or Debian first. Then you go install the Zorin package or the Zorin app on top of your base distribution, and then you boot into that. And it gives you, in this example, something that looks like Windows. Boy, that looks a lot like Windows. Chalet, that looks like Windows. Kubuntu. So here's a bunch of different versions of, or not even a bunch, there's only 4 right there. If we back up, 5 Linux distributions to replace Windows 7, best Windows. Let's click that and see what we can find it on these different sites. Linux Lite, I think I mentioned that one, Lite and Mite. Kubuntu, there's that. Again, Linux Mint, I've used Mint. My son likes Mint. It looks a lot like Windows. Ubuntu Mate, I've used Mate several times before. Also, sometimes you want what's called a lightweight OS, where you need a lightweight GUI. You need a GUI so that you can operate a mouse and you can look at web pages, but you don't want it to be this big bloated KDE or GNOME GUI environment. So you can download a lightweight environment, which gives you just enough of a GUI environment to run a browser, but it doesn't have all the fancy stuff that Windows has with it. But that's great that you can fully customize a graphical environment for yourself. Again, you cannot really do that. You can do that to some degree with Windows by installing a Windows, it's not Windows Enterprise, it's I can't remember the name of a Windows, an embedded Windows. You can download and install what's called an embedded version of Windows, which is Windows with certain apps picked and chosen for you. Certain parts of the kernel are missing from it. Let's see how much longer this is going to take. If this is going to take a lot longer, I'm just going to go into one of the PowerPoints and show you that. Yeah, that's going to take a while. So let's do this. Let's take a look at, log into Access U of H real quick. We'll take that off the screen so you don't see it. Log in real quick. MIS 4397, and this is on the Blackboard. If you want to look at this, if you're not watching this sequentially right now, you can go look at this on your own. I'm going under course content here. Let me bring this back on the screen now. Looking under course content, here are a couple different PowerPoints. Let's take a look at this first PowerPoint. Or actually, no, let's take a look at the second one, to tell you the truth. Since we're installing a GUI, let's take a look at the second one. Sometimes it's easier to understand and start with a GUI environment. Where's my chat window? I lost it again. There it is. Got my chat window back up in case you guys are typing something at me. Download this, take a look at it. And there's lots of videos and intros to Linux that you can go Google for. This is just one that I found that hit a lot of the points that I wanted to show you. This one and that first one about the command line gives you a very brief introduction to Linux. Okay. Intro to Linux. First of all, that is the official mascot for Linux. That is a penguin. And there are even distributions of Linux named after species of penguins, like Gentoo Linux. But that's the official mascot. There are many applications and packages that are developed for Linux, which are associated with different animals, like a GNU or an emu, or that's just what we do in this world. What is Unix/Linux? Now, before Linux, there was this thing called Unix, which is a multi-user operating system, which was mostly text-based, but it did have a GUI version. Back in the 80s, was anybody alive here in the 80s? So before Linux, Microsoft DOS, disk operating system, was the dominating OS for PCs, not for mainframes, but for PCs. Apple Mac was better. I don't know about that, but obviously we can tell what kind of person wrote this, but expensive. Unix operating system was a multi-user, multitasking operating system, whereas the Mac OS and the Windows OS were single-user multitasking. They were designed for a single workstation, and you can run multiple tasks. People were looking for, well, this person doesn't know English too well. I should probably have reread this. People were looking for a Unix-based system which was cheaper and could run on a PC. In other words, Linux, and this is what I helped Linus Torvalds do, Linux is a backwards compatible version of Unix. Unix was an operating system which was developed by DEC and Intel and Xerox to run on mainframe computers. We wanted to be able to do that at home on our little PCs so that we could have all the advantages of running Unix and then do development on an inexpensive PC at home and then upload our code to our mainframes once we got it running, because we didn't always have access to our mainframes at home. So backwards compatible means we took all the commands that we could find that were in the Unix system. We tried to figure out how do we make a directory command, or how do we do a listing command, or how do we move files around. And we backwards compatibly created everything. I was responsible for a lot of the networking code. There's a project called the GNU project. GNU is an animal. Stands for public licensing. Established in 1984 by Richard Stallman, who believes that software should be free. And that's generally the case with most Linux people and Linux gurus is you don't pay for the OS, you don't pay for the programs, and that eliminates piracy, software piracy, which was a big problem. You pay for the support and you pay for the rental and the usage. That's actually a much better model in most cases. There are companies making much more money renting space than they are developing applications. This is why Facebook and companies that are renting space and Oracle, they're going to make more money and they're going to be more popular than Microsoft. And this is why Microsoft is going to stop selling Office. Microsoft Office, you used to pay, actually as a student, you pay what, $9-10 for a DVD of Office. There's no such thing as Microsoft Office on a DVD anymore. It's called Office 365. It's free, sort of. You subscribe and you get a subscription to it, and you can download the code and install it on your computer, but you have to pay for it monthly. And that's because Microsoft is figuring out the way to make money is create a recurring subscription that you have to pay for every month. It allows people to afford stuff that they normally couldn't afford. Companies to afford stuff. So Linux was developed under public licensing. There's Linus. Linus is, oh no, that's Andrew. That's not Linus, excuse me. Andrew Tannenbaum developed Minix before Linus. That looks, actually, they look a lot alike. Simplified version of Unix that ran on a PC. That looks like an old Timex Sinclair PC. In 1991, it actually was before 1991. I remember talking to Linus on the phone in 1989 and 1990 about developing a backwards compatible version of Linux. We came out with Linux version 0.0.1. And then I think the first one I was working on was 0.0.15. I still have an old computer running 0.59 version of the original Linux, which is called Slackware. Actually, no, that is Linus Torvalds. That's Andrew Tannenbaum. There's another picture of Linus Torvalds. Doesn't really matter. He's from Finland. Doesn't matter. Linux today, as we know, lives on everything. There's commercial versions of Linux, but again, you're not paying for Linux, you're paying for a subscription, or you're paying for support. That's what you're paying for. There's many, many, many more installations of Linux than anything else in the world, and that's because it's embedded in everything. It's embedded in phones, smart devices, your Ring doorbells, your Simply Safes, your Samsung televisions. It's in everything. We call it free because it is free to download, and you can modify the source code of Linux. The only rules on that is that you have to share your modifications. If you make any modifications and you create your own distribution, you can't create it for in-house use only. Well, that's not true. You can't create it for in-house use because the US government has their own versions, but you can't turn around and sell that in-house version without also making available the source code for anybody to also download and modify. Because of this model of the whole world can get the source code and potentially modify it, rather than having 1,000 developers at Microsoft working on Windows, we've got 1 million developers working on Linux. So Linux has become a much more robust and a much more stable environment than Windows. How many people have done something in Windows, you've made a modification, and it says, okay, you need to reboot your computer to make these changes take effect? That's ridiculous. You should never have to reboot your machine when you make a simple change. That was one of our early mantras when we were developing Linux. We don't want to force people to reboot a Linux machine, especially if it's a server and there's 50 other people using it. Just because you want to change an IP address, you got to reboot. Screw that. So most Linux servers, you can modify a lot of stuff. You can add and delete hard drives even. Add and delete network cards, virtual network cards, without rebooting. You can put in hot swappable hard drives without rebooting. It will recognize them and allow you to start using them. Here's some different flavors. There's Red Hat. Again, Red Hat's now owned by IBM, so we don't like it, but Red Hat comes from that term. We have terms in the hacker, Mr. Robot world. You've got white hats, black hats, gray hats, which I'm kind of a gray hat, gray beard too. And then red hat, which are like hardcore developers. Black hats are bad guys. White hats are good guys. That makes sense, right? Debian, that's kind of my favorite version now, since I don't do any Linux development anymore at all. I haven't done it for probably 12, 13 years. There's a million other people all over the world doing it that are much better programmers than me, so I don't need to. There's the Gentoo Linux. There's a Linux group that you can belong to, user groups that you can belong to. There's different distributions. So in the Linux environment, you have all these popular tools that emulate all of the tools that you would use under Windows or under Mac OS. A popular word processor, or actually it used to be OpenOffice. Now the most popular package that you can download for office productivity is called LibreOffice, which, by the way, you can download and run on Windows too. It's called LibreOffice. That's not going to be homework, but I highly recommend that you download and install LibreOffice just to see what it is. You might like it better than Word. In fact, it works better than Word. How many people in here use Microsoft Outlook for their email? Outlook kind of sucks. I use Thunderbird. I don't drink Thunderbird, I use Thunderbird. Thunderbird is an open source, open system project, which is a better version of an email program. Web browser, Mozilla or Firefox. You can download Firefox and run that on Linux. In fact, that's the browser of choice for almost all Linux distributions is Firefox. When our little GUI environment is done, and we bring up the GUI, you'll see Firefox on the desktop, automatic. But you can also download Chrome. The Linux version of Chrome is called Chromium. That's their open source version. That's what the Fedora desktop looks like. Let's skip through some of this. Let's go see if our distribution finally finished. I'm going to cancel that. I don't care about that. Oh, it's done. Completed. CentOS is now successfully installed. It wants us to reboot. Before you reboot, what should you do? Here it is, 5009. I'm going to come back up here to hardware. And I'm going to eject the CD. A lot of people forget to do this. What happens if you forget to eject the CD after you've installed it? For those of you that have done this before, it tries to start the install process all over again. So remember to do that. Remove the CD drive. We don't need it anymore once we're done with the install. Now you'll notice it runs a little line through it because it's not going to take it away until I do the reboot. So I'm going to reboot here and watch what happens. Reboot. What's my password? No, 1, 2, 3, 4, 5, 6. I made it nice and simple. Feel free to check. Oh no, actually you can't because you don't know access to. I'll create some virtual machines for you guys to go look at. I find the best way to learn how to do something is see how somebody else did it and then copy it. It's not stealing, it's imitating. That's how monkeys learn. They saw another monkey do something. They said, oh, that's pretty smart. Let me do that. Or let me figure out a little bit better way to do that. Don't invent the wheel, reinvent the wheel, or figure out how to make a better wheel. Oh, Oh, okay, so here's the initial set. We're going through some post-installation setup information here. I've got to agree. Accept the end user license agreement, EULA, end user license agreement. Every program that you install always has an end user license agreement. And this basically says you promise that you're not going to sue these people if something bad happens, or you agree to use it without any warranty implied or expressed. So you got to do that before leaving, let it run. And then I don't think we need to do anything there with that because we already set that information. No, let's click it and see what it says. Yeah, we don't need to do anything there. We already turned on the Ethernet. I click finish. Let's see what we get. Are you guys excited? Ooh, look at that. It's asking me to log in as Jake, not as root, as Jake. Sign in. Ooh. CentOS. How sexy that is. Actually, CentOS 8 is even sexier. Do a little bit more post-installation fix up, but play with the mouse. Make the black mouse chase the white mouse and vice versa. So you guys could be doing this right now on VirtualBox if you wanted as well. The desktop, let's take a look at the desktop there. Now this is a very customizable desktop. You'll notice that there's almost nothing to start with on this desktop because it wants you to customize it at this point. You can hover, that's kind of like our start button there. Let's fire up a web browser. Oh, look, there's a web browser. Let's go to, where do you want to go? Go to uh.edu and see what's there. That's the Conqueror web browser. Oh, cool. There's web browser. Isn't that neat? You just made an Ubuntu machine. Looks like Apple. Yeah, it depends on the desktop that you install. KDE and GNOME kind of look like Safari. They kind of look like Mac OS. So usually in previous classes, I had people wait before they installed a GUI, but I think I'm going to have everybody install a GUI right off the bat, just because it gets you kind of excited. A lot of people have never had any experience with running anything other than Windows or Mac OS. There are other GUIs in the world. Now, we don't usually run a GUI on a server, and what we will be doing is installing CentOS and Debian and Ubuntu server virtual machines so that we can build Apache web servers, online stores, VoIP servers, firewall servers. We're going to do some specific things in this class with respect to building servers. So, let's go back to let me go back somewhere here. Let's go ahead and take a look at the command line input. And I want you to go ahead and, actually I need to find a better PowerPoint for that GUI. I didn't realize there's so many typos in it. Let's take a look at this one. This is a better one for you to use as you're starting to learn and playing around with Linux. This is going to give us some basic constructs of Linux. The goal of this tutorial is to provide hands-on training basics of using Linux via the command line. Now, just because we install that GUI, by the way, doesn't mean that we can't play around with a command line, because you can open a shell or a command line window just like you can do that in Windows by clicking here and typing in CMD. I got a text window there. That's a command line window. I can do the very same thing in Linux. Let's just see if I can find it real quick. I close this browser. I'm looking for a terminal program. do not know this desktop at all. I don't want to do that. Let me choose. Let's choose from the desktop. Oh, here we go. I can right-click and choose console. That's the same thing as terminal. There we go. There's a command line. So you can open up a console screen within this virtual machine and begin to play around. I'm logged in as Jake here, so I can't mess up anything. mkdir junk, ed junk, pwd, print working directory, just creating folders. That's all I'm doing here. So now here's what I would do if you're already doing this with VirtualBox, is install a GUI of your choice, open a terminal. I'm gonna see how far you get. I'm not grading on this, I just wanna see how many people can do this already. And start going through this tutorial. Unix is the operating system of choice for engineering and scientific and basically setting up servers. Linux is a Unix clone. We already learned that. Here's an important graphic I wanted to show you. Linux is called a kernel, an operating system kernel. In the middle of, and this is why we call these things cores, in the middle of this pie chart, it's not really a pie chart, in the middle of this graphic lives the hardware, the CPU, the hard drive storage, all of the hardware. What talks to the hardware is called the kernel. This is the most basic input-output section of the OS. Hang on one second. It's getting dry in here. Here are some basic kernel commands. Here's the shell. Here's some kernel programs. What sits on top of the kernel are optional applications which you can install, like an email application, an FTP application, a web application like Mozilla or Firefox, a database management application. So the kernel is the heart of the operating system. That's where your basic commands live, like ls for listing out a directory, cd for changing directory, mv for moving a file. There are several kernel commands in Linux that are 2 characters long. There's comparable commands in Windows, like mv is move, move. But the reason so many commands are only 2 characters is back in the old days with Unix, everything had to be 2 characters. It's a throwback to machine language. Every command was 2 characters long. So we had a bunch of already made commands programmed into our heads that move is mv. It's just burned into my brain because I'm an old guy. So let's just call it mv. We don't use dir or dir, which is what we use in Windows to get a directory listing. We use ls. List out the shell, list out the contents. So you guys are gonna experiment with, and I'll point you to in some notes, some tutorials on the Linux command line so that you can experiment around with creating directories, creating files, editing files, downloading some apps and playing with them from the command line. The command line is also called or considered expert mode. It's much faster to do things in the command line if you know the commands. A GUI is kind of like baby mode or training wheel mode or novice user mode. The command line is expert mode. Everything in Unix is a file. Keep that in mind. There are no C drive, C:, D:, E:, like you have in Windows. Thank you, by the way. Oh, bless you too. Everything's a file. If you add another hard drive, you mount that as another directory. The screen is a file. The keyboard is a file. The network card is a file. You read and write data from the screen to the screen, from the keyboard to the keyboard. And that makes things a lot easier. It makes your programming a lot easier because you can treat everything as if it's a data file or a data stream. So keep that in mind. Everything's a file in Linux. Here's what a sample, a typical command prompt looks like. So how many of you have ever used any sort of a command line prompt like this right now in Windows or otherwise? You'll notice that the cursor is blinking right there. That's called the cursor. It's blinking. Sometimes it doesn't blink, but that's just indicating, hey, I'm waiting for you to type something. It's waiting for you to hopefully type a system command or the name of a file. Usually this prompt is made up of some identifying information. Usually it's made up of the directory that you happen to be in at the time and the hard drive you happen to be in on Windows. In Linux, it's very similar, except the default is show me the username, the name of the host or the name of the machine that you're on, and then the name of the directory that you're in. So in my example here, where did it go? I'm Jake at localhost junk because I'm in the junk folder. If I type in PWD, that tells me the full path. I'm in a folder called /home/Jake/junk. By the way, in Windows, everything is a backslash or backslash. In Linux, everything's a / for folders. In other words, if I type in CD / like that, I'm in what's called the root directory. And there's folders in there. In Windows, I would type in CD // Why is it different? Microsoft made a typo. It was supposed to be /, but Microsoft made a typo somewhere when they bought Altair Basic a long, long time ago. So they said, oh, screw it, we'll just stick with the /. Somebody messed up. They used the / for something else. So keep in mind, everything in Unix is a /. A backslash does something else. Don't hit the backslash. That's for something else. A backslash is a continuation character. So if I want to change folders, I do it like that. A few files and a few folders there. Here is a generic file system layout. This is the general hierarchy. It's not always this way, but it's very similar of your file system. At the very top, you have what's called the root directory, not ROOT, not to be confused with the root user, but we have the very first directory in the system. So if you were to type in CD //, the space bar or the space is your delimiter. CD // I'm in what's called the root directory, the root folder. You rarely do anything in there, except go there to look for other folders. But if I type in ls and hit enter, it gives me a listing of all the files in there. If I do ls with a minus sign and then al, those are options. The A and the L say, give me an alphabetical long listing. That's what the A and the L stand for. It gives me a Windows style listing. It gives me the names of all the folders and the names of all the files from the root directory. Here's bin, root, dev, etc., home, lib. These are, again, this isn't, not all Linux machines have these folders, and I can create my own folders from here if I want. mkdir. Actually, I don't think I can. I'm not the root user, so it's not going to let me. I can only do stuff in my own directory. Don't have permission. There's the root user. Here's the bin directory. That's short for binary. That's usually where all of your kernel commands live. Dev, that's all where all your devices are accessed. Your hard drives, your monitors, your keyboard. The etc. folder, this is where you have a bunch of system files that are usually text files. They're configuration files, like the password file is in there. Then you have the home folder, which has all of the users underneath it. So I have, underneath home, I've got a user called Jake. I've got a Jake folder. If I created another user, like if I created Rahul as a user, we'd see a Rahul folder. Underneath each user folder, they get some subfolders. There's the lib or the library folder, which is a bunch of pre-downloaded, pre-installed applications. That's where they go. The mount folder, that's where I can mount additional hard drive space or shared storage out on the network somewhere based on IP address. The proc folder, that's a pseudo folder of running processes. The root folder, that's the actual user called root, not to be confused with the user called Jake. I can log in here and I'm going to become the root user, su minus root. 1, 2, 3, 4, 5. Oh, excuse me, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, notice how I changed to root at localhost. I'm now the root user. I have full control over the system. I can do whatever I want, edit files that I normally couldn't edit. I can screw things up too. So I have to be careful when I'm the root user. But now I could go to the root folder if I wanted to, and I could type in mkdir, make directory, joke, for example, cd joke. Now I was able to create that folder. There's the joke folder I just created. You'll notice there's the time and date has been updated. You'll notice that it's in these columns. It says it's owned by the root user. We've got some characters in the beginning here, and I'll describe what those are in just a minute here. How are we doing on time, by the way? Yeah, we're good. We're good on time. You guys are okay, right? You got nothing better to do, right? Except maybe eat dinner. Let's see if we can get through some of this, and you can follow along in this PowerPoint on your own, either now or, and I recommend that you go through this after you've installed your first Linux machine, whether you're doing it on VirtualBox or you're waiting for me to get a virtual Windows machine set up so that you can install one under Proxmox. Run through this tutorial or this PowerPoint and use it as a tutorial and play around with Linux, and then I'm going to give you some more specific assignments to do that aren't yet posted on the Blackboard to get you used to the command line. Anatomy of a Linux command. All Linux commands are pretty much built this way. Many of them are only 2 characters. Some of them are more than 2 because they're either a whole package, a whole application, or they're newer commands. So the ls command, one of the most common commands, it gives me a directory listing. A listing of all of the files and all of the folders within the directory I happen to currently be in. So it usually works like this. You issue a command, space, that's your delimiter, and then options or flags. Starts with a minus sign. In Windows, how do they do their options? They use a /. So you might do dir space /o or a special or /h to give me hidden files in a directory. A dash or a minus sign is how we execute most options of a command. So the command, then all the options come next, and most Linux commands allow you to string all the options together. Almost all the options are one single character, A, B, C, D, E, F, and not all commands have all the different options. So earlier when I was doing that ls minus AL or minus LA, I was actually stringing together a minus L and a minus A. I was putting them together into one option string, which you're allowed to do. But I could have done ls space minus A space minus L, and it would have done exactly the same thing. And then another space after all of your options, and then the object that you're operating on. So in this example, if I wanted to get a directory listing, a long listing, the R means to be recursive, and the S is another option flag. I'm not sure what the S is, I have to remember it. Give me all the files in the temp folder. In fact, let's execute that and just see what it does. ls minus L minus R minus S /TMP. Maybe nothing. Oh, there's a bunch of stuff in there. Okay, so that's giving me a long directory listing. Tells me, oh, look, there's a Jake owns a file there. So these are all the files that are currently in the temp or the temporary directory. This is kind of like, actually Windows has a temp directory too. It's just called TEMP. In the Unix world, it's called TMP because that's what it was 35 years ago when Unix was invented. Now the argument sometimes can be 2 items. For example, if I wanted to copy a file, I have a source and a target, or a source and a destination. So let's say I'm in my I'm in the temp directory here, cdtmp. I got a file there called storage.log. Let's just use that one. It doesn't have anything in it. It's a 0 byte long file. But let's say I want to copy that to another file. I use the cp command, cp-a, which means preserve all the attributes of that file. Storage.log. Now watch something. This is another thing I'm going to show you at the same time. All I typed in was STOR and then I hit the tab key. Did you guys know you could do that in Windows? You can do it in Windows and Linux, but Unix invented it, not Microsoft, not Windows. Once you type enough unique characters of a file, there's only one file in here called STO something. As soon as I've typed enough of it, I can hit the tab key and it completes it for me. Just kind of like how you're texting on your screen, on your texting app, a lot of times it'll finish the word for you because it's predictively typing. That was invented by Unix people. So I'm going to copy that file, storage log to storage, and now I'm going to copy it to copy.txt. I'm going to copy it. Okay, so I just copied that. You notice I didn't get any output. If I do -AV, by the way, I'll get some. I'll get some output. I was going to say, you sure you want to overwrite that file? Yeah, I want to overwrite it. Or here, copy -AV stores to copy to.txt. Let's do that. So the -V for most commands gives me verbose output. That's what the -V stands for. So now if I do ls space -la, you'll notice I now have a new file, a couple of new files. There's copy and copy2. Okay. So some commands have just a single argument. That's called a unary operator or a unary command. Some have 2 or more arguments, and those are either binary or commands that require multiple arguments. Move something from somewhere to somewhere else. Copy something from somewhere to somewhere else. If you're just listing out a file, that is, list this one file out. Delete this one file. That's a unary operator. Excuse me. Here's some common commands. The cd command for changing directories. The ls command, directory listing. The pwd, that doesn't stand for password, that stands for print working directory. Windows always gives you in the prompt the directory you happen to be in, but Linux, since you can be 20 directories deep, and it doesn't always give you the name of the directory that you're in. It just gives you the most recent or the most current directory you're in. But if you type in pwd, that'll give you the full path. So if I type in cd, and also you can use the little tilde to go to any user's folder very quickly. Tilde Jake if he's a user. So now I'm in home Jake. mkdir temp, cd temp, mkdir temp, cd temp. So now I'm doing the inception thing where I'm in a dream within a dream within a dream. So now I'm in a folder called home, and a folder called Jake, and a folder called temp, and another folder called temp, and another folder called temp. In other words, I'm 5 layers deep in my directory tree, in my hierarchy. Okay, we doing good so far? How many people are still with me? How many people are still awake? Nobody's got their video on, so I'm assuming some of you might not be here, but hopefully some of you are still here. I hope that you find this interesting. It's fun, I think, to learn a new thing. Keep going here. Some handy shortcuts. Anywhere in a command line, you can type an up arrow and a down arrow, and it will scroll through your previous commands. Again, Microsoft adopted that as well. So you can do that in Microsoft Windows command line. Scroll through your previous commands, but again, they stole that, or they borrowed that from Linux. I make extensive use of that. So I can scroll through all my previous commands. Also, if I think somebody screwed with my computer, like if I was on a server and I was doing stuff, then I went to the bathroom and came back, and I think somebody did something, I can use the up arrow, because this is actually persistent after I log out, and once I log back in, it's still going to give me the 50 previous commands. Or you can actually set that to go back as many as 500 commands if you want. So sometimes if I think somebody's system has been compromised, I'll log in as the root user, and I'll hit the up arrow a few times to see if I see any suspicious activity, like special commands or special applications that they install, like what's called rootkits, or remove certain files, or looked at certain files. Very handy stuff. Auto completion, already mentioned that. You can hit the tab key once you've typed enough characters of something, of a file or a directory that's unique enough. When specifying file names, if you type in ... cd space ... what does that do? Does anybody know? Same thing in Windows. cd space ... goes back to the previous directory, the parent directory, we call it. Tilde, if I type in cd space tilde, that takes me to my unique home folder. So if I'm logged in as Jake and I'm in some other folder somewhere and I need to get back home real quick, I can click my heels 3 times and say there's no place like home, or I can type in cd space tilde and get to my Unix home or my Linux home. Star is the wild card, just like in Windows. Star. By the way, if you want to really screw something up, you can use the remove command. If I were to, I have a t-shirt with this printed on it, which I used to wear everywhere. In like heavy Linux gurus know what I'm talking about. If you type in rm -rf / what do you think that will do? rm space -rf / what do you think that will do? Take a guess. The rm command, what does that sound like? What does that sound like? Remove, that's right, remove. In other words, delete. The rf, do you know what that says? That means do this recursively. Remove everything. The F means to force it. In other words, don't warn me, hey, you're about to remove everything. You sure you want to do that? Yeah. Or in other words, we call the F the fuck you. Excuse me, but we call that the fuck you option. It means force it. I don't give a crap. I know what I'm doing. Force it. And then if you do the / it says go back up to the parent directory and remove everything under it. That will destroy a Linux operating system. It removes everything. It's done. So you put that on a t-shirt, you walk around and you get some Linux newbies say, hey, you should do this sometime. It destroys their Linux machine. And don't ever do that, by the way, okay? That's the same thing as going into Windows and typing in fdisk c : / r. Remove that partition. You don't want to do that. So you got to be careful when you're and this is why all modern Linux distributions, like we just installed there, they force you to create another user. If I had not created that user, Jake, it would have, during that post-installation setup, it would have said, hey, you need to create a user. Give me a username. And I would have had to type in Jake, and okay, what you want your password to be, here it is. Just like Windows does that. And that's because they don't want to encourage people to always be the root user. The only time you want to be the root user is if you really do need to have root access or admin access to remove some system file. But usually, type in exit. Usually you just want to be that, I logged out of the root user, now I'm Jake again. So now if I typed in RM minus RF / it's going to say, no, you can't do that. You are not the root user. And all the files are still there. Now, what you might want to do too, and this is something that you can only do in a virtual environment, if you really want to do an RM minus RF just for grins and giggles to see what it does, what could you do to experiment? You could take a snapshot. That's why I mentioned that snapshotting thing. So here's my CentOS test, which I just created. I'm going to take a snapshot. I'm just going to call it before destruction. OMFG. Take a snapshot. I recommend that you do this during your experimentation. You're going to make a typo. You're going to make a mistake. The bad thing about the expert command line mode is if you mess up one character, you type in a 1 instead of a 0, or a / instead of a /, or you typed in a Z instead of an R, you could render your system unusable. So if you want to do something and you're not sure if you're doing it right, take a snapshot first. And it takes a little longer on this GUI, but so now I've taken a snapshot. Now I'm going to go back to it, and I'm going to do a very destructive, stupid thing. Again, don't do this, but you might accidentally do something like this. So I'm going to become the root user again. / 6, and I'm going to type in RM minus RF / Oh, I have to use some additional options. Actually, well, CD / I'm going to remove everything in the etc. folder. Oh, busy. And well, I remove some things. Remove minus RFV for verbose. What else can I remove? Bin. Wow, I just removed all the commands, so now I probably can't do anything. Oh my God, the LS command. I bet the RM command is gone. Now I can't remove anything. I've totally effed myself just now. It's like, oh my God, I've deleted all the commands. I can't do anything. Print working directory, I can do that one. But I can't do LS. I don't even think I could change folders. I can't do CD. No, I can't do CD, thank God. There's a few that are built in, but I'm effed at this point. Thank God I made a snapshot. So I can go back to my virtual environment. You can do this in VirtualBox too. Go here to before destruction, and I'm going to roll back. I'm going to go back in time 5 minutes ago before I did that dumb thing. Now, it'll probably reboot the machine because I did a very destructive thing, and it'll reboot it, but at least I'll get back to where I was. Okay, so during this class, during this semester, I want you to make extensive use of taking snapshots, not just taking backups. You do want to do backups, but making a backup and restoring a backup is a much more time-consuming procedure. I just literally did a rollback within a few seconds here. And the only reason is because I didn't change, I did only a few things. The way snapshotting works is it literally is just a bookmark at one point. As long as I don't change very much, I have very little to roll back to. Now, if it's 3 months later and I have to do a rollback, yeah, it's going to take an hour or so to roll back 3 months worth of changes. But if it's tomorrow and I roll back to yesterday, it might take 5 minutes or 3 minutes. It won't take that long. So now I'm recovered. Let's see if I can get back to that console. Let's see if it's working. And actually, it didn't reboot. Sometimes it does, sometimes it does not. It depends on what you did. Oh my God, it's back. I'm saved. So what do you guys think? Pretty neat so far, right? So I'm going to go ahead and end the class now because it's almost 6 o'clock. I'll post this video, and I'm also going to work on, like I said, creating these Proxmox environments. I'll send out emails, and you're going to log into your Blackboard, and you'll notice a new column in Blackboard. And actually, there's this column now, and it tells you what team you're on. Once you know what team you're on, then I'll give you instructions on how to log into your remote virtual machine. I'm going to have to send individual emails, I guess, on that. What virtual machine I've assigned you, how you get to it. I'm probably going to use TeamViewer, by the way. So you might as well download that now. How many people have used or ever heard of TeamViewer? Not TeamViewer, but TeamViewer. TeamViewer is probably a porno site. Don't go to TeamViewer. Go to Team. Accept the cookies. Yeah, me accept cookies. Sorry, Cookie Monster. So go download that free version of TeamViewer. By the way, whenever you download free software, be very careful because invariably there's always these little tiny check boxes in the corners that says, I also agree to download this new browser or this new virus checking software or this new crap in the background you don't want. Make sure you uncheck those boxes. Also, when you download any software, usually in the install procedures, it asks this very innocuous question. Would you like to help us make your experience better? What is that doing when you click it? Like when you install Google Chrome, for example. Would you like to help Chrome have a better experience? Check this box, yes. What do you think that's doing? That's giving Chrome or giving the Alphabet company permission to gather statistics on your usage. Now, is that necessarily a bad thing? No, Alphabet and Chrome and Google are probably not spying on you, but again, they're using your information to generate survey data. They're trying to figure out what your behavior is so they can basically do their research. But what that does is it installs a little program in the background. It's called a TSR, Terminate and Stay Resident Program, which is a separate process that runs all the time on your computer. And although it doesn't use a lot of processes, it slows things down. Also, in our 4477 class, we make use of Wireshark and all these programs that people install that also have these little secondary background processes running. They are generating data in Wireshark, which is data we don't want to see. So, like, for example, if you open your task manager underneath, at least under Windows, let me move this around. Hang on one sec for me. Where's my task manager? Where'd she go? Oh, here it is on the other screen. So if you open your task manager here in Windows, and I know you can do this in a Mac, I just don't know where it is. Here's the applications that you're running, but look at all this other shit running. What the hell is all of this? Some of it's necessary, some of it's important stuff, but I'll tell you, there's a bunch of other stuff going on in the background that you don't need, like, you know, Java update process and Adobe Reader updating and Google Chrome experience. And this is all survey, not all of it, but a lot of it is survey collection processes. Look at all those processes running. Many of these don't need to be running on your computer. Again, they're not taking up a lot of CPU cycles, but they're taking up some, and they're taking up your bandwidth. So my point is, when you're going to install anything, whether it's Chrome or TeamViewer or this advanced IP scanner, which I was asking the 4477 class to install, be very aware of these little check boxes, and they're usually down in the corner, and they're buried, or they're very innocuous. They, like I said, they ask you questions like, would you like to help make the world a better place, yes or no? Well, yeah, sure, I guess I want to make the world a better place. It's because legally they have to ask permission before they install these other ancillary programs on your machine that we as technicians and we as server managers don't want. We don't want this extra noise going on our workstations, especially in a virtual environment, because these are shared environments. It's not a high-powered environment that we're creating. If you're not the only person using this machine. Like in the case of my VMware that's in here, I create every semester between 90 and 110 Windows virtual machines, 50 of which are all running at one time. 50 versions of Windows running at one time on 2 servers. Probably some things are going to slow down a little bit. So I try to make very streamlined, very lightweight versions of these workstations. So that's what I'm going to work on. I may just make Windows 7 workstations available in the interest of time. I know Windows 7 has been sunsetted and we're supposed to all be on Windows 10, but Windows 7 is still very out there, very ubiquitous. The federal government just barely got off Windows XP. In fact, the FBI, it's interesting, a lot of people think you want, and I'll stop here. If you guys need to go, that's fine, but I just want to make a couple of social commentaries. You watch these, let me stop sharing my screen because I'm kind of done here. But so you watch these episodics, CSI, Law and Order, and these cop dramas where they're using very sophisticated computer systems and 3D rendering things and stuff that's floating in the air with see-through monitors and all that. Our government, although we're one of the richest governments in the world, we don't spend that kind of money on a field officer that works for the FBI. There are a lot of FBI agents and IRS agents that are working. They're still using old 10-year-old laptops with XP on them. So the government doesn't have the latest and greatest stuff. So it's really funny for me because, again, I have cousins that work for Microsoft, and I also have cousins and family that work for the government and Department of Defense. And I've seen their computer systems and what they have to use. So it's really amusing when I see this totally futuristic stuff going on, because that's what Hollywood thinks. That's what Hollywood believes the FBI is like, or CSI is like, but that's not true, and it's amusing and funny. So I'll see you guys later. I'll follow up with emails and announcements. So check Blackboard later with the new information. But in the meantime, if you can, download VirtualBox, download some flavor of Linux, and start playing with it. Start learning how to use Linux. See you later. Go Cougs.